What's the square root of 49? Meaning, what number times itself is 49? If you answered 7, you're half right. The complete answer is 7 and negative 7. 7 times itself is 49, and negative 7 times itself is 49. 49 is a perfect square. A perfect square is a number whose square root is a whole number, like positive and negative 7. The square root of a number like 50 is going to end in a messy decimal amount that needs to be rounded off. 50 is an imperfect square. Let's take a quick look at estimating square roots. The square root of 921 is going to be a two-digit number. 20 squared is 400, 30 squared is 900, and 40 squared is 1600. So we know that the root of 921 is going to be somewhere between 30 and 40, and probably much closer to 30. 30 would be a good estimate. We can determine the square root of any number, perfect or imperfect, through the following method. It's very similar to traditional division. Let's find the square root of 576. The first step is to group the numbers in pairs, radiating from the decimal point in both directions. In other words, starting right to left before the decimal, and starting left to right after the decimal. After pairing, a single remaining digit on the end can be considered a group. Here are some examples of correct groupings. .576 is understood to be equal to 576.0, so we know where to start grouping. Find the square root of the first group, which is in this case single digit 5. If it's not a perfect square, find the closest perfect square just below. The closest perfect square just below 5 is 4, which is 2 times 2. So we write 2 as the divisor and 2 in the quotient place. 2 times 2 equals 4. So we'll write that 4 under the 5. Subtract 4 from 5 and you get 1. Bring down the next group of numbers, and the number being divided is now 176. At this point we add the most recent quotient digit to the divisor to make a new divisor. So 2 plus 2 equals 4. The next step is to affix a number to the divisor and then multiply it by the number affixed to it. That's hard to explain, but easy to demonstrate. .41 times 1 equals 41. In this case, we're affixing the number 1. 42 times 2 is 84. In this case, we're affixing the number 2. 43 times 3 is 129. And 44 times 4 is 176, and so on. By affixing 4 to the divisor and 4 to the quotient, we end up with 44 times 4, which gives us 176. 176 minus 176 is 0, and we're done. The answer is 24, and we also know that 576 happens to be a perfect square because we have a remainder of 0. Actually, 24 is only half the answer. The answer is positive and negative 24, which is notated like this. So here are the rules. Rule 1, after each step, always add the last quotient digit to the divisor to make a new divisor. Rule 2, a new divisor gets multiplied by the number which is affixed to it. What's the square root of this number? Well, the first step is the grouping. And starting with the first group, what times itself equals 53? Well, it's not a perfect square, so let's find a perfect square just below it. 6 squared is 36, 7 squared is 49, 8 squared is 64. 64 is too high, so let's go with 49. 49 is 7 times 7, so write 7 as the quotient and 7 as the divisor. And we write 49 as the product of the two. 53 minus 49 is 4. Bring down the next group. Add quotient 7 to divisor 7 to get 14, and that's the new divisor. So the divisor is 14, and the new number being divided is 429. Now we need to find a number to tack onto the divisor 14 and the quotient. 141 times 1 is 141. 142 times 2 is 284. 143 times 3 is 429. That's the number we want because the remainder will be 0. The square root of 5329 is positive and negative 73. Now let's try an imperfect square, 9.87, which gets grouped like this. 9 is 3 times 3, so write 3 for the divisor and 3 for the quotient digit. And 9 gets written under the 9. 9 minus 9 is 0, and bring down the 87. Add the divisor digit 3 to the quotient digit 3 to make 6. So now our divisor is 6, and the number being divided is 87. The next step is to append a number. 61 times 1 is 61. 62 times 2 is 124, which is too high. So the next quotient digit is 1. 1 times 61 is 61. 87 minus 61 is 26. Add the divisor 61 to the quotient digit 1, and your new divisor is 62. We can continue this process infinitely by bringing down more and more zeros to as many decimal places as we want, or we can finish the problem by normal division, which will give a close approximation. In either case, we round off after a given number of decimal places. If we're ending with normal division, we're dividing 62 into 26, which will give us digits 4, 1, 9, and the quotient is 3.1419. Rounding to 2 decimal places, we get 3.14. So the answer is positive and negative 3.14.